on your investment. Again, if you're comparing mutual fund A with fund B or ETF A with B or C. So depending on how you measure risk, if you measure risk with the standard deviation of that portfolio that you are evaluating, yeah? Then the first thing we can do is what? The Sharpe ratio that you've already learned. That is, RP minus RF divided by sigma P, right? So making sure in your Excel formula, the RP minus RF has a parenthesis around it because you're taking the excess return or risk premium first and then adjust it by dividing by standard deviation on your portfolio, yeah? And we already said all these R's are what? They are the simple average. Sum up your sample returns divided by the number of observations or number of returns in your sample, right? So in our case, 2 years weekly data, so you should probably have around 104 weekly returns, add them up, divided by 104, or just use the average function in Excel, right? Same thing for RF. Why? Because this RF is historical collection of risk-free rate returns, so it has different numbers for each week. Collect them all, add them up, divide by 104, just use the simple average function, okay? And then for the standard deviation, again, you have 104 observations of returns on your fund, right? And then just use the standard deviation function and get the Sharpe ratio. And we already said, the higher the Sharpe ratio, the better the performance, because for each unit of risk measured by standard deviation of the portfolio, higher Sharpe ratio means what? Higher return, more return, and that's, of course, that's what we want, yeah? And it doesn't matter if this Sharpe ratio is positive, great, wonderful, negative, don't be scared. Negative just means what? Your portfolio, your fund does not even return as high as the risk-free rate, but yet it has higher risk. It still has a bunch of risk, right? So the negative Sharpe ratio, no good. The more negative, even worse, right? So that is the first one we start. And if you understand this one, adjusting portfolio return with risk, then you will understand the trainer measure. Trainer measure, the only difference here is what? The risk measure on the portfolio, on the fund that you're evaluating. This time we are just looking at the systematic risk, the market risk. We don't look at the total standard deviation, because standard deviation is total risk. It has systematic, it has firm specific, but we just look at the systematic, the beta, yeah? So similarly to adjust return by its risk, this time you're gonna divide the excess return on the risk premium by the risk measure, and risk measure is beta. The only difference here is what? Beta, sometimes, depending on the fund, the sample, the time period, you may have a negative beta estimate. Most of the times, you shouldn't have a negative beta estimate, but sometimes, empirically, the data just shows up negative. If that's the case, we say what? Making sure you take the absolute value of the beta here when you try to adjust for risk. Why? If you remember last time we said, the volatility, how volatile your investment is the magnitude of the beta, whether it's 0.8 or 1.3 or 2.5. Whether it's positive or negative, it just shows you how this investment goes either in the same direction with the market or goes in the opposite direction of the market. So the sign of beta is just a direction, but how volatile it is the magnitude of beta. The higher the magnitude of beta, so absolute value, the higher that magnitude, yeah, the more volatile your stock or your investment is. So that's why in here we have to take the absolute value just in case you run into a negative beta. Now, if of your 3 ETFs, active ETFs you choose for your project, is all 3 of them have positive beta, then you don't have to worry about this, because absolute value of a positive number is still the same number, right? So that only happens when it's negative beta. So far, you guys still with me? And the same logic as Sharpe ratio applies here. The higher the trainer ratio, the better performance that fund has, because for the same units of systematic risk, the fund give you more return, right? If it's negative, don't worry about it. Negative means it's not very good. The return on the fund, what? Cannot even catch up with risk-free rate, yet it has higher risk. It has higher beta. Yeah? So far, you guys still with me? So these two are pretty easy. Again, the same thing here with your RP, RF. These are all simple average. And you can calculate from your data, okay? So these two, based on your data, you can do it for each fund. And then the next measure, continue with using beta as the risk measure, only look at systematic risk, is what? Is our CAPM alpha, or we call it Jensen's alpha, just to remember him. Michael Jensen, a professor. So this alpha here is the same alpha we have been talking about, in the security market line, that's the same alpha. Okay, and we have multiple ways of calculating this alpha. But if you look at this alpha, why it can be an investment performance measure is what? Is because, by definition, this alpha is what? Is the so-called abnormal return that cannot be explained by CAPM, right? So what can be explained by CAPM? Well, that goes to our famous CAPM equation, RF times plus beta P times RM minus RF. So this part is what CAPM says based on the risk of your fund, beta P, systematic risk. Based on the risk of your fund, CAPM, that little equation says this fund should give you so much return. Yeah? All in that parenthesis. So based on the systematic risk of the fund, beta, the fund should give you X% of return, but the fund actually give you Y% return. So that's why the difference here measures the abnormal return, what cannot be explained by CAPM systematic risk. So that is your alpha. So same thing here is your simple average for your fund over 104 weeks. Same thing, simple average of the market risk premium, which the Fund of French website has the data. All you need to do is just take simple average. Beta P, you already estimated using either the slope function or using the regression tab. They should give you the same number. Remember all that? So all you need to do, plug in that, get the alpha. So this alpha here, as you can tell, is also risk adjusted by using systematic risk beta measure. So it kind of goes together with the trainer measure in the sense that when we adjust for risk, we use beta, we use the systematic risk. So far, you guys still with me? And this alpha measure, this is just by its definition, and then in your project, what did I say? Make sure you double check it, you triple check it using the what? Intercept function, using the regression tab. They should give you all three of them should give you exactly the same number on this CAPM alpha. Okay, so far you guys still with me? All right, so we already talked about that project, so in the Excel sheet, so I'm not gonna repeat that. So, this is CAPM alpha, Jensen's alpha, and then because this alpha can be estimated using a regression framework by regressing what? Regressing the fund's excess return on market excess return. So if you draw the regression line, RP minus RF for your fund, RM minus RF for the market, these are your 104 observations. Each one of them is a pair of RP minus RF, RM minus RF. So when you draw the regression line here is alpha, slope is beta, but all these dots, your 104 dots, they're not gonna be all on that regression line. Regression line is just trying to fit a straight line that best describes your data, has the smallest distance to your data. So each one of them will have what we call residue. Each one of them has a little distance to the regression line. And this residue in my thing is called EI, okay? E. So this residue, if you look at the standard deviation of this residue, we call it the tracking error. So basically your regression line, your single factor model, how much does it deviate from the data, or how good is the data tracking this model? So this standard deviation of the residues is your tracking error, and based on this tracking error is what we call the firm-specific risk, okay? Your regression line with the beta as the slope, that's your systematic risk for this fund. But this fund also has firm-specific risk measured by those residues, okay? Standard deviation residues. So now the next step of finding a performance evaluation is based on this alpha, so the intercept here, I'm gonna adjust this alpha again, but this time since alpha is already adjusted by beta, the systematic risk, this time I'm just gonna adjust the alpha by the tracking error or the residual risk. Basically firm-specific risk, okay? So divide alpha by tracking error. And when you divide alpha by tracking error, you get something called the information ratio. So the idea here is the same. The higher the information ratio, the better the performance is, because for a same unit of firm-specific risk measured by tracking error, you have higher of the normal return alpha. Again, positive, wonderful, the more positive, the better. Negative, not as good, but at least what? The less negative is better than the more negative, okay? So same thing, same idea. So as you can tell, all these measures trying to adjust return or normal performance by risk involve some type of dividing the risk, yeah? Only that we either divide by total risk, standard deviation, or you divide by systematic risk, beta, and this time you divide by firm-specific risk or tracking error, okay? So far, you guys still with me? So far, you guys still with me? All right. Then what do we say? After this CAPM model, calculating alpha, tracking error, information ratio, we can extend all this alpha, tracking error, information ratio, so IR here stands for information ratio, to all the other pricing models. And the one that we learned most recently is the Fama-French three-factor model. So far, your alpha, your tracking error, your information ratio is based on CAPM. CAPM is a model, but now let's use a different model. Okay, so this time the model is the Fama-French three-factor model. And you can calculate exactly the same thing. The alpha, the intercept, the tracking error, the standard deviation on the residues, and then take the ratio of the two to get the information ratio. Okay, so you're gonna do that for your 3 active ETF funds one by one as well. So alpha is just gonna be the abnormal return that cannot be explained by the model. And in this case, it's the 3-factor: the size, the market, the book-to-market ratio. Yeah, the same factor that the Fama-French website has. And then you get the intercept, you get the residue that Excel generates for you. You take the standard deviation of residue, you get what? Tracking error, and then divide your alpha by the tracking error, you get your information ratio. So here we go. Okay, so small minus that is one factor from French's website. High minus low, that is what? High book to market ratio minus low book to market ratio, that's the other factor. French already got the data for you. And then risk-free rate, and market risk premium. So French gave you all these 4 numbers for each week. Yeah, you collect them, and then for your fund, you gotta collect their price, get the return, get the risk premium. So don't forget why your dependent variable in the regressions is always risk premium. Okay, so you gotta minus that RF there. So all you need to do here is what? Data analysis, regression, making sure you let Excel know that your Y is your fund's risk premium, so highlight everything. And then your X, this time you have what? Multivariate, so it's not just one X, it's what? It's 3X, yeah? So this 3 factors from Fama French. This thing won't let me track. Come on. So I am still in the monthly here, but in your project, you're gonna be weekly. So making sure if your data includes the variable name, like what I did here, so making sure you click on labels so that Excel know your first row is labeled, and then making sure you want Excel to calculate residue for you, and later on you can double check all that, right? And then you can click OK, and Excel will generate a bunch of stuff. Over here, what's the most important is right here. The intercept coefficient from the Excel table here is what? What is that intercept? That intercept is this particular fund's alpha, very good, from the Fama French 3-factor model, okay? So again, alpha from KPM is a different model. Alpha from Fama French 3-factor is a different model. So this is your alpha from the Fama French 3-factor model. Okay? Because this is a multivariate regression, you have 3x variables here, the market factor, the size factor, the book to market ratio factor. You cannot use the intercept function or the slope function. That is only for a single x. Yeah? So over here, you can only use the regression. And you got your alpha. Excel, what? Generate the residual. So for your tracking arrow, you just need to calculate the standard deviation of the residual. Okay? So, and you just need to calculate the standard deviation of all these residuals that Excel calculated for you. And then you take the alpha here divided by the standard deviation of the residual, that's your tracking arrow, you get your information ratio for this fund from the Fama French 3-factor model. Okay? So that's what I did here. Okay? Standard deviation of the residuals, and then information ratio, just alpha divided by the standard deviation, the tracking arrow. Okay? But what I also ask you guys to do is what? To double check, triple check, check what? First of all, see if you understand what Excel generates for you. The predicted risk premium and the residual. How did Excel do that? Last time we talked about it. The predicted value, so the predicted value of the Y or of the risk premium is just you fitting the alpha and the beta estimation to every observation. Okay? So as you can see here, what I did for observation 1, the first observation is I'm just plugging in what the regression results coefficients are, alpha plus beta 1, so the coefficient here is beta 1, beta 2, beta 3. Okay, each beta corresponds to a factor. Beta 1 times what? Times the first observation on the market factor, yeah? And then beta 2 times what? times the first observation of the size factor. Beta 3 times the first observation of the book to market ratio factor. Okay? That's it. That's basically fitting your regression coefficient estimates back to the data one by one and see what the regression predict your y is. Okay? And I do that for every single observation. Of course, you can copy paste. So if you look at predicted value, where is it? Okay, 2 is right there. So all I need to do is I'm still using the same coefficients estimates from the Excel output, but this time I'm fitting it to the second observation of my data. Yeah? So beta 1 times x1, beta 2 times x2, beta 3 times x3 for the second observation plus the alpha. I get my predicted value. So what I'm doing here is basically trying to find where on the fitted line, on the regression line is. Okay? So far, you guys with me? That's the predicted value. So my predicted value calculating this way, fitting every observation to the coefficient estimate, should be exactly the same as what Excel generates. Now, when Excel generated, if you click on it, it doesn't have any formula, but I am double checking it using my own way, and these two numbers should be exactly the same. So that's why I have 7, 8 different decimal points there, just to make the point that they are exactly the same. And you need to do that too, okay? Similarly, Excel generates all these residuals with no formula embedded. I want to double check it. So what my residual is, is just the predicted value, the difference between the real y, here for the first observation, real y, and the predicted y. That's my residual. That's the difference here. The real y said, given all this x, your y, your dependent variable, your fund's risk premium should be this much. Okay, that's the predicted. And the real said, well, I'm right here. So what's the difference? That's the difference for each observation, and that's your residual. Okay. And then you can double check the residual from what your calculation versus what Excel generates, and it should be the same as well. Okay? So far, are you guys still with me? So this is just double checking everything. And then to calculate the tracking error, I already said you can just use the simple standard deviation function of all the residuals for all your observations. But you can also double check it using the tracking error definition. What is the tracking error definition? Tracking error definition is residual squared, add them up, divided by t minus 1 for the adjustment of degree of freedom, excuse me, and then take the square root. So that definition there for tracking error is the same definition that I have right here. Same thing, okay? Right here, sorry, right here. It's the standard deviation of the residuals, it's the square root of the variance, and the square root is from this function. So that, I'm just using its definition to double check. And again, it should be exactly the same as if you're just using the standard deviation function on the residual. Once you get the tracking error, once you get the residual, once you get the predicted value, once you get all those double check, triple check, then you can go ahead and calculate your information ratio as alpha divided by tracking error. Okay? Do this for every fund, every one of your 3 funds, and then of course you can see who has the highest information ratio, who has the lowest, and then rank them. Okay? So far, you guys still with me? So far, any questions? All right. So right now, you already learned alpha, tracking error, and that smile scares me. That shows. Okay. Right now, you've already learned what? Alpha calculation, tracking error calculation, information ratio calculation for either CAPM, single factor, market factor, or Fama French was 3 factor. So you already learned that, right? So 2 models fit into the alpha calculation and all that. Lots of times people want to just simplify things. Who doesn't like to simplify things? So in your Saluki Student Investment Fund and some of these other professionally managed funds, what they can do is, in addition to CAPM and Fama French 3 factor, and later on they may have Fama French 5 factor, they may have momentum factor, they may fit it into all kinds of factor models. But the simplest way is, instead of using a pricing model to see what the return should be, because all these pricing models basically serve one purpose, is based on this model with these risk factors, what the return should be and what the actual return is. Yeah, that's what we are doing here. So what people say is, well, let's not use any pricing model. Let's just use the underlying benchmark, because every fund is compared to its benchmark, right? So let's just forget about CAPM, forget about 3 factor, 4 factor, 5 factor, 100 factor. Let's just use the benchmark. Okay, so that's what we call the simple alpha. Your fund's return minus the benchmark return. Okay? Right here. Simply the difference, relative return between your investment or the investment you're trying to evaluate and the benchmark portfolio. Okay? The difference there is the simple alpha. And then how do you adjust that simple alpha by risk? Well, we just take the standard deviation of that relative return. Okay? That's your tracking arrow. Standard deviation of that simple alpha, and then you will get the tracking arrow. Once you get the tracking arrow, information ratio is just alpha divided by its standard deviation. Okay? So that's the third thing you guys need to do for your alpha tracking arrow information ratio calculation for each fund. And I just ask you to use the Fama French market as your benchmark. So for all your ETF that you choose, just use the Fama French market, comparing that to the market portfolio that French has already collected for you on his website. Okay? So far you guys understand what we are trying to do here? For the simple alpha, is just the market return. Now, Fama French has the market risk premium, but Fama French also has the risk-free rate. So all you need to do is what? Is to add up these two to get to your market return, right? And that, use your market return and look at your portfolio return, and portfolio return minus market return, and you will get your simple alpha. Okay? You get your simple alpha, you get a standard deviation of it, divide the two, you get your simple information ratio. So far you guys still with me? I'm not showing you how to do this because this is pretty straightforward. Okay, but don't forget, to get to the market return, you gotta add up these two to get RM, and then you already have your fund return, and then it's just the average of the fund return minus the average of the market return, you get your simple alpha. Okay? All right. So pay attention, when you talk about information ratio, the higher the better, adjust alpha by the risk, making sure the alpha and the tracking arrow is all from the same model. So if you're using CAPM, then it should be CAPM alpha divided by CAPM tracking arrow. You get CAPM information ratio. If you're using Fama French 3 factor, then it's what? Fama French 3 factor alpha divided by Fama French 3 factor tracking arrow. You get Fama French 3 factor information ratio. If you're using the simple alpha, by just subtracting the benchmark market, then it's what? Simple alpha divided by the standard deviation of the simple alpha, then you get the information ratio from the simple alpha. Okay? in your mind, if you haven't gone through this far, you should know that, you have three ETFs, one for each, right? And then you collect data for each one of them. You calculate Sharpe ratio, trainer ratio, CAPM alpha, CAPM tracking error, CAPM information ratio, and then you calculate Fama fringe 3-factor alpha, Fama fringe 3-factor tracking error, Fama fringe 3-factor information ratio, right? And then you calculate what? Simple alpha, tracking error from the simple alpha, and information ratio from simple alpha. So you calculate this for each one of them, then, you can rank your 3 funds, okay? According to Sharpe ratio, fund A is better than B than C, According to trainer ratio, fund C is better than B than A. It may be different, okay? It may have different conclusions, but at least you can rank all your 3 funds according to each measure, based on, what each measure is for each fund, right? So you probably will need to have a force sheet there, just kind of compare all the funds with each measure. That's with everything listed there, then you can see, you can present it clearly who has the highest for which measure, okay? All right. The next 2 measures, and we're not done yet. You think, man, gosh, why are there so many measures? Because there are different ways of adjusting for risk. Next 2 measures are connected as well, okay? They share exactly the same logic. The only difference here is one used standard deviation to measure risk, one used beta to measure risk. Just like Sharpe versus trainer. Same thing, same logic, but different risk measure. One is called M-squared measure, one is called T-squared measure. So as you can tell, how they adjust for risk is through creating hypothetical portfolio of the fund that you are trying to evaluate with the risk-free asset. So they're combining your fund with the risk-free asset, okay, in certain combination weights. But when they create this hypothetical portfolio, we call it P star, they're trying to line up P star's risk with the market risk, whether it's market standard deviation or market beta. Okay? One way or another, they're trying to make this hypothetical P star that's from P and F, okay, to have the same risk as the market. And then they just compare P star's return with the market. Because if you have the same risk as the market, then you can just look at the return difference. Okay, that's the whole idea here. So to go through that, we will do some calculations. Okay, and as we do the calculation, the sample calculation, you will see exactly what lining up with the market means. Okay, so here we go. I will give you guys about 3 minutes or so. Try to see if you can do everything: Sharpe, trainer, Jensen's alpha, information ratio. And then once we are at M squared, T squared, you can stop and I will show you the steps. Okay?